Okay, so let me just go over all this real quick. So last time we defined uh, Fourier series. We defined these functions, cosine and sine n pi x over L, and we saw that they form an orthogonal set. And we defined so-called Fourier series of a function. So if I have a function periodic with period 2L, say f of x, and we assume that it is integrable. It doesn't have to be continuous. Integrable is fine. I can define its Fourier series like this. And the reason we call this gadget Fourier series of f is the following. In general, this function, this whole thing defines a function. Of course, it's a question whether this is convergent or not. But assume it is convergent. It is still not immediate that this is equal to f of x. Okay, because this is an infinite sum, and why it has to be equal to f of x. That's why we just call this gadget the what? Fourier series of f. And the reason is the following, why we call it Fourier series of f. If the series is convergent, and suppose we call this function as g of x, then we can show that the Fourier series of this function is indeed this series. And here is the computation for that. We just compute the Fourier coefficients of g using our formula. We compute all these integrals, and we see that if I have cosine m pi x over L, I get am, and similarly, if I have sine m pi x over L, I will get bm. Okay, so that's the Fourier series business. Geçen ders bir örnek yapmıştık. Bir tane daha yapalım mı? Ben hangi fonksiyon yapmıştım? Şeydi değil mi? Bu step function'ı yapmıştık. Tamam. Tamam. Bir tane daha yapalım. Let's do one more example. Another example. Find the Fourier series of f of x, which is this function. Okay, x, if x between minus L and L, and then okay, şöyle yazayım. X minus okay, ya da şöyle diyeyim. And extended to R periodically with period to L. Yani şunu kastediyoruz. So we have this. From minus L to L, it is X. So it is this function, L and minus L. So it is this function here. And then it is extended periodically. So 2L, 3L. So it will be like this. İsterseniz şu uç noktaları katmayayım. Şöyle olsun. Tamam. Uç noktalarda ya da birini katalım, birini katmayalım. Şöyle. Şurada şöyle olsun, burada böyle olsun. Burada böyle, burada boş. Biri boş, biri dolu yani. Okay. Minus 2L minus 3L. So again, the same thing. Okay. So this is full, this is empty, and so on. And it goes like this. So you draw one of them and then you copy and paste. Okay. Tamam mı? Şimdi bunun Fourier serisi nedir? Okay, so an is what? An is just ya da a0. An şuydu. 1 over L times minus L to L f of x times cosine n pi x over L dx. Okay. Well, this function is just x times cosine n pi x over L dx. So we have to do integration by parts. Yok, gerek yok ona. Well, we will do integration by parts, but this one is trivially zero. Why is that? This is an odd function. Cosine is an even function. So the product is odd. Integral of an odd function over a symmetric interval is just zero. So this is just zero. What about Bn? Well, for Bn, we have to do integration by parts because that won't be zero. So let's do that. Okay, now what is Bn? Bn is 1 over L minus L to L f of x sine n pi x over L dx. So it is 1 over L times x times sine n pi x over L dx. Okay, this time, we cannot play the same trick because, well, we can play the same trick this way. This is an odd function. This is an odd function. Odd function, both of them. So the product is even. And since this is even, this integral is just 2 times the integral from 0 to L x times sine n pi x over L dx. So it's a simplification this way. Okay, so this is just 1 over 2 over L, and then we apply integration by parts. Let's call this as u, and this is dv. So this is just uv, I'm sorry, 0 to L minus 0 to L v du. 2 over L. What is u? U is just x. This is dv. So what is v? V is minus L over n times pi cosine n pi x over L. Yes, and we compute this at 0 and L minus integral from 0 to L v du. V is this, du is just 1. So bu da eksi, bir eksi de burada var, artı oldu. L bölü np cosinüs np x over L dx. All right. Well, integral of this is sine, and I will put here L and 0. In sine, if I put L here, I will get sine n times pi, which is 0. When I plug 0, sine 0 is 0. So integral of this will give us only 0. So I can just forget about it. And we have only this. So this is just 2 over L. When I plug L, I get minus L squared over n pi and cosine n times pi minus I plug 0. Well, if I plug 0, this will just kill that gadget. So cosine n pi times this. Cosine n pi is just minus 1 to the power n. So this is just 2L squared over n times pi times minus 1 to the power n plus 1. Right? L'lerin birisi de sadeleşti. Evet. Yes. Okay. So what is the Fourier series of f? Hence, the Fourier series of f of x is what? 1 over 2 a0, right? Plus n 1 over L vardı. Değil mi burada? Var mıydı? Ha, A'ları hesaplarken var. Burada yok. Evet. N from 1 to infinity an cosine n pi x over L plus bn sine n pi x over L. So all an's are 0. There is only bn's, and it is just from 1 to infinity. And bn is just 2L over n times pi and minus 1 to the power n plus 1, and then sine n pi x over L. Yani şöyle yazabiliriz. 2L over payı dışarı alalım. So n from 1 to infinity minus 1 to the power n plus 1 divided by n times sine n pi x over L. So our function has a sine series, değil mi? Of course, you know, if you have an odd function, it will have sine series because cosine terms will vanish. And if you have an even function, this time sine terms will vanish. So you will have a cosine series. Okay. You may, as say that, this was a very simple function, just x function, and we write it in a very complicated form. But, this has other advantages. Of course, for the function x, this may look confusing, a lot more complicated than the function is, but you can actually represent any function this way, and to represent this function, all you have to do, you have to just record a-n's and b-n's. So any function is just a sequence of real numbers, a-n's and b-n's, and that's a very big advantage because we have very big space of functions. Function space is very big, but you can represent any function by a sequence of real numbers, just coefficients a-n and b-n's. So that's why this is a very powerful method to represent functions. Evet. Efendim? Bazı fonksiyonlar için eşit olacak. Yani her fonksiyon için bunlar birbirine eşit değil de. Ama hani eşit olmadığı durumda da şimdi onu yapacağız. So let's see the theorem. So theorem is this. The convergence of Fourier series. So when I say Fs, it means Fourier series, not the beer or the ruins. Okay. Let f be a function on this interval. C2 means it's twice differentiable and the second derivative is also continuous. Okay, it is a continuous function. First derivative is continuous and the second derivative is continuous. Okay, twice continuously differentiable. Function on minus LL. Be such that f minus L f L'e eşit olsun and türevi de eksi L'deki türevi de L'deki türevine eşit olsun. So both the endpoints and the derivatives at the endpoints agree. Let an and bn be the Fourier coefficients of f of x. So this is just integral from minus L to L f times cosine n pi x over L divided by L and so on. Okay, Fourier coefficients of f of x, and let m be the maximum of the second derivative on this closed interval. I can talk about this maximum because double prime, f double prime is continuous, and it's a closed interval. A continuous function on a closed interval has a maximum, and we call that maximum m. Then the conclusion is then for any n greater than or equal to 1, this absolute value f minus the Fourier series, okay, Fourier series, and from 1 to infinity, an cosine n pi x over L plus bn sine n pi x over L. So I have the original function minus its Fourier series. Fourier series is another function, and I look at the difference between these two functions, and the conclusion is that this is less than 4 times L squared m divided by pi squared times n. Bu garip bir şey. Ne demek yani her n'den küçük? O zaman 0 olması lazım, değil mi? Ha, herhalde şunu kastediyor. Şurada bence n var. Okay. Öbür türlü anlamsız. This should be n. I guess there's a typo there. So if I take just the first 2n plus 1 terms, değil mi? N tane kosinüs, n tane sinüs, bir de sabit terim 2n artı 1. However, if you let n go to infinity, of course, the right-hand side goes to 0. Therefore, the series converges to f of x uniformly. In particular, as n goes to infinity, the Fourier series converges to f of x uniformly on minus L to L. Okay. Bir tane daha şöyle bir teorem var. Zamanım var değil mi? Öyle mi? Okay, so let's give a break. After the break, I'll continue.